Hey, what's happening, guys? Today we are going to build a kit. But first, an announcement. You guys have all seen the videos of the Intnl 8008 multimeter. Just one of the best multimeters out there, low cost, lots of features. Well, I'm teaming up with one of my sponsors, Banggood. You guys have seen me do lots of videos from Banggood. And we're going to give an Intnl 8008 kit to one of you guys, and the best part is, this is not limited to just the US. Anywhere in the world that Banggood delivers, they will deliver one of these to you if you are the lucky winner. So how do you get to be the lucky winner? Easy. Leave a comment down below telling me that you want to be the lucky winner. And on Labor Day of this year, which is Monday, September 3rd, we will draw the winner randomly from everybody who has commented down below. You must be a subscriber, and you must be able to receive deliveries from Banggood. So I don't care where you live, if they can get it in there on Camelback or Flying Monkey or whatever, you're eligible. That being said, let's get started. Today we're going to do a kit build, and this is from Spark Fun. This is the X000 R6 TLDF breadboard power supply USB 5V 3.3 volt DIY kit new, and it's from Amazon. And if it's worth a crap, then I will put it in my Amazon store. There's an ant. Get the hell out of here. All right, so PRT 08376 Spark Fun breadboard power supply USB blah blah blah. Let's see what's in the kit, because I got a feeling this is going to be a really easy kit build. Alright, we've got a USB Type A power jack. Why Type A? Couldn't we just go with a USB micro like everybody else in the world's using? We've got a single pole, single throw, yeah. Switch it now, double throw, I guess. Sort of goes from one to the other. There is our breadboard. Very nice. And we have some components. The main component of which is probably going to be this IC here, which I am guessing, yes, is an LM317T. Let me get everything laid out here and ready to go, and we'll build this bad boy. Alright, there's not a lot here. There's our PCB. There's the LM317. We've got a couple of multi-layer ceramic capacitors, a couple of electrolytic capacitors, a 5mm LED, some header pins, our switch, our USB power supply, and 4 teeny tiny little resistors. Let's build this. I think it'll be fun. So, you can see here we got ground 5V, ground 3.3 volt. There's spot for multi-layer ceramic, couple spots for our electrolytics. Yeah, this is going to be really easy to build. 240, 330, 330. It looks like we only need 3 resistors. I wonder why they gave us 4. Okay, let's get the resistors in there first. Okay. So, after looking, those are different. That one says 390, and that one says 330. We'll start with our 240. Then we have our 390. And our 330. It's just the general consensus that you start with the smallest components first. I mean, you're welcome to buck the trend if you want. No big deal, right? Alright, got it clamped in the helping hands. Got the old soldering iron here ready to go. And let's give it a shot. See if we can't get her soldered in there real nice. Again, you always want to apply the heat to the pad and the component, then bring in the solder. Once the solder melts, you take the solder away, then you take the heat away. Now we'll do the other side here, and then we'll clip the leads off real nice and easy. Now this kit is definitely more expensive than buying one of the little breadboard power supplies, which I mean you can probably get for less than $1 from China. But there's two reasons to do a kit like this yourself. Number one is it's fun and you're learning something. So let's whoops, sorry, but I keep bumping the camera. So let's put those two together as education and entertainment. And secondly, you're supporting an American company. So that's always nice. There we go. We've got our resistors in there. Real nice. All right, what should we do next? I mean, it really doesn't matter at this point. Although another place I seem to have made a slight mistake was saying that there are two multi-layer ceramic capacitors, when in fact there's one multi-layer ceramic capacitor and one PTC, which is a positive temperature coefficient thermistor, and that would be this guy. Since it is a heat item, we're going to put it in last. All right, let's go with the switch next. How about that? So switch on off. Now I turn that over, it's probably going to want to fall out, so I'm going to have to secure it in some way. I see a lot of the British guys using the blue tack. I don't really have that here. I mean, I'm sure I could look around and find it in some store, but I'm not aware of it, and I'm just going to use a little bit of Scotch tape. No big deal. I'm trying hard not to bump the camera again. Sorry about doing that before. Camera's on a swing arm. Basically, once I get one of these soldered in here, it should be good. Yeah, that'll work. No problem at all. See, I soldered in there pretty nice. Then we'll just clip off the nipples or nip off the clipples, however you want to call it. Okay, now we'll put in the multi-layer ceramic. This is a 0.01 microfarad little cap, so we'll put that guy in there. We'll get him soldered in real quick. I do like building kits. It's relaxing, to me anyway. The noise in the background is the air conditioning. It's 92 degrees today and about 100% humidity. Yes, that is a solder blob on the side there, and I don't like that joint, so we're going to have to redo it. I think that'll be better. Sometimes just a little reflow is all you need, and I still don't like that joint. Now sometimes this happens. Sometimes you can get a board that doesn't want to play nice. You can just try a reflow, which I did the first time. You can try adding some more solder, which is what I'm doing this time. And if it still doesn't want to play nice, I guess it's alright. Generally what I would do next is add some flux to it, because sometimes you just have to flux the joints. Alright, so next we got a couple of electrolytics. We have a 10 and 100. Here is our 10. Goes right here. There is our negative side, so I'm going to make sure that I put the negative to the negative, because I messed that up in, I think it was the piano kit that I built. And thank goodness you guys called me on it. Sometimes I just don't pay enough attention because I'm talking and I'm trying to think of what I'm going to say next while I'm building the kit. So if you guys see a mistake, feel free to say something. You know, like we say here in the U.S., see something, say something. Okay. I should take care of that real nice. I want to thank Banggood if they're watching. I know they don't have a lot of access to YouTube in China, but I want to thank them for always being around to help out the channel. And when I asked them if we could do a worldwide giveaway, you know, they had no problem with that. They were right on board. So if anybody from Banggood is watching, thank you guys so much. You know, it shows the folks that are watching you're not just out to make a buck. You're out there for the community, providing the stuff that we need at a great price. Like I said, I greatly appreciate it. And I'm sure my viewers greatly appreciate it. And that AN 8008 is an absolutely fantastic multimeter. I did a review on the 8009 just recently, and like I said, there really wasn't too much of a difference between them, other than they changed a couple features. We're putting in the LM317 now, which is a silicone-based linear voltage regulator. Uh-oh, I thought it was going to stay. That's alright, if it doesn't want to stay, we just give it a little bendy, and there won't be any problem. But I did just completely forget what I was talking about. Oh, the AN 8008 and the AN 8009. Fantastic little multimeters. You know, yeah, sure, they lack the high voltage protection of a Fluke. But you know what? None of us who are playing around in our home labs or in the schools really have any use for a Fluke. I mean, yeah, sure, it's great to have, but you don't need it. It's not required. And then somebody told me about a new one, the AN Q1. Well, I've got one coming next week, and it looks really interesting. So I cannot wait to play with it. Yeah, we should be about done there. We got a couple headers put in, our PTC, and finally our USB. So let me see if I can get that USB in there. Alright. We'll solder this guy in. I had a feeling this would be a really easy kit. Again, yes, I know it's more expensive than buying one of these super cheap little Chinesium ones, but hey. Like I said, two things: it's educational, and you're helping out a nice company that's here in the U.S. And that is saying something, because there aren't too many electronics companies left, especially for this kind of electronics. I mean, we've got SparkFun and basically Adafruit, and really that's it. So I find that if I can give them my money, I will. I'm going to have to look there to make sure that I didn't create a solder bridge. You guys can probably see better in the camera than I can actually see with my own eyes. So I'm going to grab some wick and I'll be right back. Alright, I was able to take care of it, no problemo. So we got a couple things left. We've got an LED. We'll put that guy in there now. Just going to bend those legs so it stays in there nice. And our PTC. I'm going to put him in there next. And also bend those legs. Then we'll solder them both up at one time, and that'll leave us with the headers, and this little project will be done. Now back to the Intnl multimeters. I saw that Kangaroo Jack did a review on the Q1, but I haven't watched it because I want to go in cold. I don't want any, preconceived notions. And it looks like a really neat multimeter. I thought originally that it had an OLED screen, but it's not. Although it's still looking pretty good. It'll be interesting. I'm going to take it outside and use it in some different lighting conditions so we can see how that white on black holds up to the conditions in which you just might be using your multimeter. Because if it's no good where you're going to be using it, then it's no good anywhere. Alright, so all we've got left are the headers. Let's pop them in next. They're going to be interesting to solder, aren't they? One moment. To solder those header pins in, I am going to use a breadboard because, that's how we'd be using this thing, right? So that's the ground. I think this is how they want us to put this together. So yeah, there we go. Now a little two-step soldering process to make this nice here. Let's zoom in. So what I'll do is I'll hold that like there, solder in one pin. Then what I'm going to do is reflow it, hold it in the position that I want until it cools. Then I should be able to let go. Maybe. That's better. So there's our 5-volt. Now what we'll do is we'll pull that out and basically do the same thing for the 3.3 volt. Hopefully we can find a spot. There, see, that'll fit nicely right like that. Interesting design, but hey, I am definitely not a design engineer, so don't, that's just my opinion. And of course, opinions are like assholes. We all have them and they all stink. Okay, and our final joint of the day, something that no stoner ever wants to hear. And that should just about wrap up our soldering, right? Okay. let's test it out. All right, let's test it out. We can start with the 3.3 volt first. Yeah, why not? So I will plug that in like that. So we have 3.3 into the red and the ground into the blue. We'll put some power to it. Maybe. Wow, I don't want to go in. There we go. Power off. Power on. Okay, power off. Now, let's put in an LED. I'm not even sure what color this LED is, but we will run it like this from the power rail. Then we'll put a 330 ohm resistor, cross it to ground, and I see another ant. Then we'll just link up our grounds here. Ground 1, ground 2, and if I turn it on, hey, how about that? It works. Let's take a voltage reading, right? Bring in the one of the A-nings, huh? How about that? How about not the 8008 today? How about I grabbed the 8009? Hold on. All right, there's the 8009. We'll power it up and get a different set of leads. Hold on. All right, these are just the standard leads that come with it. And let's see what we get here out of the 3.3. 3.4, that's looking pretty nice. How about the 5 volt? Okay. That's showing 3.1, but that might just be the way it works. We might not be able to get output out of both of them. Let's find out what happens if we put the 5 volt in here. There we go. Now the 5 volt is powered up. Let's take a measurement across that. Huh. Get in there. Okay. I don't know about you guys, but I'm not seeing 5 volts. Let me here's what we'll do. We'll put a couple of just leads in here to make it easier for ants, to make it easier for me to connect. And we'll grab those other leads that just have the mini grabbers on them. And we'll try and get a reading this way. Alright, so there we go. Ground, VCC. Okay, there we go. It was just a connection problem, which is kind of what I was figuring. Alright, I guess you guys will want to check one more thing before we go. Let's look at it on the scope and check the ripple, right? Okay, I've got the scope hooked up in parallel with the load and with the meter. Let's roll on up here and have a look at the scope. Now we're going to have to make some adjustments so that we can get a good look at the ripple. So the first thing I'm going to do is I'm going to go to channel 1 menu. and I'm going to couple it AC. The next thing I'm going to do is I'm going to turn on the bandwidth limit, and then I'm going to zoom in here. Now look at that. Alright, now we're going to go to the trigger menu. Edge type source, channel 1, mode is auto. That's good. We're going to grab some cursors. And it's going to be cursors. They'll be manual, and they will be voltage type. Alright, let's go with the first one. Let's get everything right where we need it here. Just adjusting. Okay, that'll work for now. We'll skip out the big bumpers. Throw in the small ones. Make sure we catch the small ones. And we will call that a ripple of 116 millivolts. Not great. Not bad. Not great. Somewhere just in the middle, right? Okay, let me pop this off of here, and let's go back to the 3 volt and see if there's any difference in the ripple there. Yeah, I mean, there is. I wouldn't say it's considerable, but there is some difference in the ripple from the 3.3 to the 5. Yeah, this ripple's 82, so we're looking at 116. So 20 and 20. So it's a difference of about 40 millivolts. You know, definitely there's ripple there. But for what we're using this for, I seriously don't see a problem with that. I think it's working okay. I think it's a nice project. It's a very easy soldering project. It would make a great first project, maybe a second project, you know, somewhere where you're trying to get started. And I think that's where we'll end today. I hope you guys enjoyed this. Don't forget to comment down below if you want the meter giveaway. And big thanks to all the patrons. That's it. I am out of here. Peace.